Have you ever found yourself pondering the workings of a nuclear reactor? If so, you're in the right place. Today, we delve into this fascinating world of nuclear energy, breaking down the complex process into simple, understandable steps. First off, what exactly is a nuclear reactor? In the simplest terms, a nuclear reactor is a machine that uses nuclear reactions to generate heat. This heat then gets used to produce steam, which powers turbines to generate electricity. It's much like a conventional power plant, only the heat source is different. Dive a bit deeper and you'll find that the heart of a nuclear reactor is the core. The core contains fuel assemblies, which are rods filled with small pellets of uranium-235 or plutonium-239. These elements are fissile, meaning they can sustain a nuclear chain reaction. A nuclear chain reaction begins when a neutron, a subatomic particle, strikes the nucleus of a fissile atom, causing it to split, or fission. This fission releases a great deal of energy in the form of heat and radiation, but importantly, it also releases more neutrons. These newly freed neutrons can then go on to strike other fissile atoms, causing them to fission and release more heat, radiation, and neutrons. This creates a chain reaction that, once started, continues until stopped or controlled. Now, this process is carefully controlled in a nuclear reactor with something called a neutron moderator. The moderator slows down the fast-moving neutrons, making it more likely for them to cause fission when they strike a fissile atom. Commonly used moderators include water, heavy water, and graphite. Control rods are another crucial component. Made of materials that absorb neutrons such as boron, silver, indium, and cadmium, they're inserted or withdrawn from the core to control the rate of the nuclear chain reaction. If the reaction starts getting too fast, more control rods are inserted to absorb more neutrons and slow it down. If the reaction is too slow, some control rods are withdrawn, allowing more neutrons to continue the chain reaction. The heat produced from these fissions is utilized to convert water into steam. This steam then drives the turbines, which are connected to generators to produce electricity. Finally, it's important to mention that the spent fuel rods, now full of radioactive waste, are carefully removed and stored in special facilities to prevent any harm to people or the environment. And there you have it, a nuclear reactor in a nutshell. Just to summarize, a nuclear reactor uses nuclear reactions to generate heat. This process begins with a neutron striking a fissile atom, causing it to split and release heat, radiation, and more neutrons. These neutrons then continue the chain reaction. The reaction's rate is controlled with neutron moderators and control rods. The heat produced is used to create steam, which drives turbines and generates electricity. Finally, the spent fuel rods are safely stored away as radioactive waste. It's a complex process, but one that powers millions of homes and businesses around the world. It's the intricate dance of physics and engineering that sits at the heart of nuclear power.